Okay, so let's talk about completing the square, specifically where the leading coefficient is 1. So the x squared only has a 1 out front. All right. Okay. Let's talk about first why we want to do this. So we want to do this because we learned that it's very easy to graph and it's even easy to solve quadratics as long as they're in this form. Right. So if they're in this perfect square form, it's actually vertex form because in this form I know that h and k, that's the vertex. And A is just a linear stretch, a vertical stretch. So it's easy to graph and it's easy to solve. And so we really want to develop a way to get a general form quadratic, so the x squared, the x, and the c, into this vertex form. Right? If we could do that, then we'd be able to graph things easily and solve things easily. Right. So to do this, let's talk about perfect squares. As you'll notice in vertex form, this is an x minus h squared. That's a perfect square. So let's start with perfect squares. So I'm going to factor x squared plus 2x plus 1. Right? So if I factor that, I need the factors of the first. So x squared is x times x. I need the factors of the constant, which is 1. So it's 1 times 1 and negative 1 times negative 1. And I got to find the combination that adds up to 2x. Well, that's simply just 1 times x plus 1 times x. So to factor this, it'll be x plus 1 times x plus 1. So this actually is a perfect square. It's x plus 1 squared. All right. So if we just take that, what if we were just given x plus or x squared plus 2x? So I'm just not given enough to do the perfect square to factor. I'm only given an x squared and a 2x. I'm not given enough, right? And what I really want is that I want that plus 1. I want to be able to factor this as a perfect square. So I want that plus 1. So if I add that plus 1, I get what I want. But the problem is now these two aren't equal. Right? I've just changed the expression. So this is a wonderful trick in math. What we're going to do is add a very clever 0. So I'm going to add a plus 1 and then a minus 1. So in essence, this is 0. So really, this is just changing the way something looks without actually changing what it is. So by doing this, I get the x squared plus 2x plus 1 that I really want, so I can make that perfect square. And I also have this 0, which means I didn't actually change the expression at all. So that's equal to what I started with. So it's very nice. So now let's do it. Let's factor out x squared plus 2x plus 1. And that is just x plus 1 times x plus 1. That minus 1 just comes along for the ride. And then I'll get an x plus 1 squared. And so this means that x squared plus 2x is the exact same thing as x plus 1 squared minus 1. And in fact, if we were to do distribution and multiply this out, we would have x squared plus 2x plus 1 minus 1. They'll cancel. So that's why it's x squared plus 2x. All right, so you can see you give me an x squared and an x, and I can do some clever adding zeros, right? Then I can factor and get a perfect square. That's the deal. All right. Okay. So stop the video and you want to complete the classwork, the first page. It's a little bit of factoring and completing the square. All right. There's a little table. Let's try an example here. So let's say I just want to complete the square on x squared plus 6x. And so again, I'm not given everything I need. I need that constant to make a perfect square. So just make a note, right, that x plus 3 times x plus 3 would be x squared plus 6x plus 3 squared. Now, how did I know it was x plus 3 times x plus 3? Because when we factor, remember, this is going to be this is going to be x times 3 and a 3 times x is 6x. So all I really need to do is cut this number in half, and it'll tell me exactly what my perfect square is going to be. All right, so it's a nice little trick, and that comes straight from distribution. Right? If I have a perfect square, which you'll see, I'll have a 3x plus 3x. That's how I get 6x. I'll have two of the exact same things added up to be this term. All right, and we saw that in the actual perfect square from before. Okay. All right. Well, if that's true, then I know that what I need is a plus 3 squared. So let's do our cool trick where we add 3 squared and subtract 3 squared. So I'm getting what I want in the blue so I can factor, and I'm actually just adding 0, which means I didn't change anything, right? So again, we're changing the way it looks, but we're not changing the expression. So let's factor the blue. That's just x plus 3 squared, and then the 3 squared is 9, so that's minus 9, all right? So x squared plus 6x is the exact same thing as x plus 3 squared minus 9. Okay? All right. Let's try one more. So x squared minus 8x. So let's do our trick. This is 8x. If I cut it in half, that would be a 4, right? A minus 4. So I know my perfect square is actually x minus 4 times x minus 4. And you'll see if I multiply it out, I'll get an x squared, then I'll get a minus 4x minus another 4x, which is minus 8x, and then I'll get these two terms squared, or multiply together to be a square. All right? But that's the trick. You cut that middle term in half, and that'll tell you what the perfect square is going to be. All right, so now I know what I need to add. I need to add a negative 4 squared. So I'll add that, and I'll subtract it. So remember, I have to add a 0 so I don't change the actual equation at all, or in this case, the expression. All right, so now that I have an x squared minus 8x plus 16, right? So if I square that out, I can factor that into x minus 4 squared. And then the red just stays along with the red. All right, so that means that x squared minus 8x is the exact same thing as x minus 4 squared minus 16. All right, that's our deal. Okay, so stop this and you want to complete classwork problem number 1. All right, so now what if I have a larger expression? So now I actually have that general form quadratic. It's x squared plus 6x plus 4. So I actually have what I need, or I may or may not have what I need. So there's a couple ways you can think about this. I would do it, well, this is how I do it, right? So I take it as I just look at the x squared plus 6x, right? So I know that I can take an x squared and an x and complete the square, so I'm only going to look at that. And so you'll see if I cut this in half, that's a 3. So I know that I need to add 3 squared and subtract 3 squared, right? So I'm going to forget all about the 4. I'm just going to let the 4 come along for the ride. All right, so and I'm going to add 3 squared and subtract 3 squared. There are other ways you could do it. If you know that you have to add and subtract a 9, you can, or if you need a 9, you can do some other numbers, or you can do some manipulations. But I think this is the easiest. Just keep the 4 along for the ride and do what we did before. So I know that the x squared plus 6x plus 3 squared is x plus 3 squared. I know that 3 minus 3 squared is negative 9. So then at the very end, I'll put these two constants together. So I got an x plus 3, the whole thing squared, minus 5. So that means x squared plus 6x plus 4 is the exact same thing as x plus 3 squared minus 5. All right, so it doesn't matter if I have a third term or not in the beginning. I just treat it, or I just keep it along for the ride. So I just look at the x squared and the 6x, and then I complete the square on that. Okay? All right. So stop this, and you want to do classwork problem number 3. All right, so lastly, we're going to look at if we have an equation. So let's complete the square on this equation. All right, and again, I look at my pieces. All I need is an x squared and an x. So I have an x squared minus 6. I know that if I cut the 6 in half, that's a negative 3. So I know that the number that I need to make a perfect square is a negative 3 squared. So I'm going to add a negative 3 and subtract a negative 3, just like I did before. All right, so that'll equal 4. So last time I had a plus 4, and this time it's equal to 4, but either way, I just keep it to the end. All right. Okay, so now you can, if you want, since this is an equation, you can balance the equation. So whatever I do to one side, I'm going to add negative 3 squared here. I could have actually just written it like this. Instead of putting my minus negative 3 squared on the left side, I could just do balance the equation. So I'm adding a negative 3 squared here, so I'll add a negative 3 squared here. Okay, you can do either one. I like the second way. I like this because it saves a step, but it really doesn't make any difference. So either do your clever 0 all at once, or balance the equation, which is actually just adding a 0. Right? So when you balance equations, it's really just adding zeros. Okay, so now I know the blue turns into x minus 3 squared. Right, I can factor that into a perfect square. And the right side is just 4 plus 9. All right, so I'll get an x minus 3 squared equals 13. So I turn this equation into a perfect square equation, right, which is extremely handy. It's a very powerful tool because now I can solve it easily. Square root both sides, add 3, I'm done. All right, and we'll get to that later. But that's how I would put square on an equation, or within an equation. Okay, it's actually the end of the video, so stop this and just complete classwork problem number 7.